Hi, I hope you are doing well. In this video, we will try to see central limit theorem in action. To start that, let's find out the definition of central limit theorem, and for that, let's go to Wikipedia. So here we are. I go to Wikipedia, and here you can see a definition which says in probability theory, the central limit theorem states that under appropriate conditions the distribution of a normalized version of the sample mean converges to a standard normal distribution. So this is the definition. If you did not understand that, there is one more here in simple words which says, in other words, suppose that a large sample of observation is obtained, each observation being randomly produced in a way that does not depend on the values of other observations, and the average, which is arithmetic mean, of the observed value is computed. If this procedure is performed many times resulting in a collection of observed averages, the central limit theorem states that if the sample size is large enough, the probability distributions of these averages will closely approximate to the normal distribution. So we are going to utilize just these 4 5 lines, and we are going to practically see how actually this works. For that, we will do a simulation of rolling a dice. So when we roll a dice, we can get maximum 6 numbers, and we are going to utilize them. So for that, let's create one Excel file. Let's search Excel here, and then one Excel file will open something like this. And then what we are going to do, we are going to simulate dice rolling. For that, we are going to generate numbers, and we know that dice can have maximum 6 numbers. So we are going to create those 6 numbers with the help of rand between command in Excel. So let's do that. Let's say random number 1 here, and let's create some more columns of these random numbers. So when I will roll my dice first time, whatever I will get, I will write down here. When I will roll it again, I will write down here. When I will roll third time, I will write down here, and when I will roll fourth time, I will just write that down here. Let's roll it for the first time. So for that, I say rand between, this one I am going to use, and I'm going to say generate a number between 1 to 6. So which just simulates a dice, and I'm going to extend it for all these 4 rounds. So here we see. So now I was able to generate these 4 numbers. So this I will say my first trial, and in my second trial I can say something like this, and in my third trial I can again repeat whatever I did. In this one I can pull this down, so this will be my third one. So you see, I use this rand between in all these cells. Whatever I wrote, I just repeated it several times. Now I'm going to take average of these. You may be wondering why I am doing that, and I will just explain that in a bit again. So I just take average of these 4 numbers, and I repeat this for these remaining 2 as well. So what I did so far is nothing but, if you see here, um, we haven't yet had large samples of observations, but we had some samples of observation, which is in our case just these 3. This is my first observation, this is my second, this is my third. So here each observation being randomly produced, which in our case is, and it does not depend on other observation, which is true in our case, and the average arithmetic mean of observed value is computed. So this one here, you see, these values are the averages we just computed. Now what we are going to do, we are going to follow this procedure. If this procedure is repeated many times resulting in a collection of observed averages, then central limit theorem says that we will be reaching to the probability distribute that we will be saying that the probability distribution will be reaching to the normal distribution. So we are just trying to follow that exact same process. Now we also want to count how many times these happened, just like we read here. Here we are calculating these averages and we will be just making a note of that. So we will say numbers or averages, we can say average, and then frequency. So what are possibilities in this case? So the possibility is that all of these are one same number. For example, 1 1 1 1, and if we take average, so then this will become 1 plus 1 plus 1 plus 1, 4 divided by 4, because these are four numbers, so they will sum up to 4, and we will divide that by 4 because we are going to take average. So at this place minimum value we will get is 1. So I will just write down 1 here because that is the minimum value we are going to get. What would be the next number we will get other than 1? Next minimum number, that would be, if we get 1, if we get 2 at one place and remaining places remain 1, so that will make it, let's say 1 1, so that will make it 4 divided by 4, let's say 2 1, and then that will make it 7, not 7, 5 divided by 4, 1.25. So next number we will have will be 1.25, and like that. I will just delete this because these were the numbers we created and we did not randomly generate them. I will delete them, but we understood that what is going to be the pattern of these averages. So 1.25, next number will be 1.5, and next number will be 1.75, like that. So we will extend this until 6 because that is the maximum number we can have. Now let's find out the frequencies of these numbers. So if you say frequency, and then data array, our data array is this, and bins we are creating or taking from here, so we say this, and then we were able to find out the frequency. Now let's extend this for all these data sets. Let me redo it actually, or let's say count if, and then we say range, and we say this. So what countif function does, it counts only when it finds 1 in this list. So we are saying go to EE range, this is our range. In EE range, all the data set is range, count only when you find this h2 is nothing but the 1. So whenever it will see 1, it will count. Currently there is no 1, so it says 0 here. Let's extend this until here. So now what we have done so far, we generated some numbers, we found their average, and we counted how many times that average was present. Now if we try to plot this, that's what our central limit theorem says here. So if we try to plot this, it will look, it doesn't look very nice, and we cannot say whether this is a normal distribution or not. That is because we did not create enough samples. We have only 3 samples. Let's go and create more samples. Let's pull this down, and you see now it looks more like a normal distribution. So how did that happen? Because we increased lots of samples and we followed this exact same procedure, we were able to get something which looks like a normal distribution. So these were the frequencies of these data sets here with the averages, and it looks like a normal distribution. If we create even more samples, if I go further down, now we have done only 403, we can pull it down further and it will look even better. So you see, as we increase these sample sizes, it becomes better and better. I hope this helped. You can also convert this to actually PDF of normal distribution, which is probability distribution function of a normal distribution. So um, for that, what you can do, you can utilize norm dist function of Excel. So let's utilize that, and it will need two things as arguments, that is average and standard deviation. So let's calculate that average, that is average of this, and let's say standard deviation we will calculate for the sample. So here is our standard deviation and average. Let's calculate the PDF. We use norm dist, this one you see returns normal distribution for the specified mean and standard deviation. So we click over here, our x is this and our mean is this. We need to also fix it with F4, comma, standard deviation we have is this, we also need to fix it with F4, comma, we want to get probability mass function, so we will use this false here, and we will close this, and we will extend this for all the rows we have. And now if we, now this we can say PDF or PMF, and if you plot this versus this, you will see a normal distribution which looks a perfect normal distribution. You can also make a line plot on this. So you can see we started with just some random numbers from here. We, in a way, we started with rolling a dice, we took its average, and we continued doing this for lots of times, and then we have just noted down the frequencies of these averages, and we were able to reach to a normal distribution just with this very simple activity. If you increase it even further, you will see a very nice normal distribution graph, but anyway, this at this stage also looks nice, and this just confirms this we have just read here in this page. I hope it helps. If you have any doubt, you can comment and I will try to answer. Thank you.